All right, everybody, we're going to look at some systems of equations solved by substitution. So we'll have another round of this, and hopefully this video will not cut off the edges, and we'll be able to show everything. So what I'm going to start with is I've got 145 points, and I've got 2-point questions, and I've got 5-point questions. So we're going to let x equal 2-point, and we're going to have y equal 5-point. And I've got 50 questions, so I've got 50 equals x plus y. So what I'm going to do is I'm going to solve for y. So I'm going to have 50 minus x equals y. So wherever I see a y in the original, or the first equation, I'm going to substitute 50 minus x. So I've got 145 equals 2x plus 5 times 50 minus x. So I'm going to distribute. Now that I'm into one variable of x, I'm going to solve this equation for x and then substitute back in to find y. So I've got 145 equals 2x plus 250 minus 5x. Go ahead and combine these two, and I get 145 equals negative 3x plus 250. And I'm just going to add the 3x to the other side. And now I'm going to subtract the 145. And I'm going to get 3x is equal to 105 divided by 3. X is equal to 35. All right, what does that mean? That just means there's 35 2-point questions on the exam. So wherever I see not this direction, but if I go over here and substitute an x in here, I'm going to get 50, subtract 35, and that should give me y. So 15 is equal to y. So my ordered pair would be 35, 15, which means there's 35 2-point questions and 15 5-point questions. Looking at example 2, I've got the Lakers and the Bulls. Lakers played against the Bulls. The Lakers scored 80 points. And my question is, how many 2-point shots, how many 3-point shots? So x will be 2-point and y will be 3-point. So if the Lakers scored 80 points, we know they had so many 2-pointers and so many 3-pointers. But they had 37 baskets total, so it'd be x plus y. So I'm going to solve for y here, so 37 minus x equals y, and again, the reason that's easier to do is because the coefficients of x and y are 1. So wherever I see in the first equation a y, I'm going to substitute 37 minus x. So over here I'm going to get 80 equals 2x plus 3 times 37 minus x. Again, I'm in terms of x's, so when I solve this equation, I'll know what x would be, which would be my 2-point baskets. So I'm going to distribute. So I get 80 equals 2x, and I'm going to get 111 minus 3x. So I'll go ahead and combine those, and I get 80 equals negative x plus 111. And I'm just going to add x over here, and then I'm going to subtract 80 kind of in one complete step. That goes to 0, that goes to 0. So I'm left with x is equal to 111 minus 80, and I get 31. So what does that mean? Well, that means there was 31 2-point baskets. So if I just substitute back in here, I'm going to get y is equal to 37 minus 31, and y is equal to 6. So the ordered pair 31, 6 means something. 31 2-point baskets and 6 3-point baskets. Next problem. Looks like there's Stefan selling tickets at the school, and they've got a first day and they've got a second day. So it looks like X would be your senior citizen tickets and Y would be your child tickets. So it looks like day 1 and day 2. So the first day they sold 3 senior tickets, 1 child, and they made $38. And then the second day they sold 3 senior, 2 children, and made $52. This is the equation right here that I'm going to solve, and I'm going to solve for y because the coefficient is 1. So y is going to be equal to 38, and then I'm just going to subtract the 3x. So wherever I see a y over here, which is right there, I'm going to substitute 38 minus 3x. So I get 3x plus 2 times 38 minus 3x is equal to 52. Again, I'm in one variable of x, so when I solve this, I'll know how much the price of a senior ticket would be. So that's going to be 3x plus, that's 76 minus 6x is equal to 52. I combine these terms and I get negative 3x. And I'm going to subtract the 76. Well, no, I'm going to keep the 76 here. And then I'm going to subtract 52 and add the 3x. That goes to 0 and that goes to 0. So on this side, the left side of the equal sign, I'm going to get 24 is equal to 3x. So x is equal to 8. What does that mean? Well, if 8 is the senior citizen ticket price, that means it's $8 per senior citizen. And then if I take 8 and I substitute it right here for x, I'm going to get 38 minus 3 times 8, which would be 38 minus 24, which would be 14 for a child ticket. So the ordered pair 8, 14 means something in this problem. $8 for senior citizens, $14 for children. All right, senior classes at 2 different high schools. Senior class at student A, they have vans and buses. So we're just going to say X would be a van and Y would be a bus. So high school A had 1 van, 6 buses equals 372 passengers. Second high school had 4 vans plus 12 buses, and that equaled 780. This top equation here is the right candidate for solving for substitution, because I'm going to solve for x because x has a coefficient of 1. So x would equal 372 take away 6y. So wherever I see an x over here, I'm going to substitute 372 minus 6y. So 4 times 372 minus 6y plus 12y is equal to 780. Again, I'm in terms of y, which means it's going to tell me how much a bus can hold and carry. So I'm going to distribute. And 4 times 372, that's going to come over here. That's going to give me 1,488 minus 24y plus 12y equals 780. So I'm going to combine these two. So I've got 1488 minus 12y is equal to 780. And now I'm just going to add the 12y over here. And I'm going to subtract the 780 over here. Oops. Fix that. And that's going to go to 0. And that's going to go to 0. 1488 minus 780. So my work comes over here. And I've got 708 is equal to 12y. And if I divide by 12, I'll get y is equal to 59. What does that mean? That just means how many students a bus can carry. So in my ordered pair over here, I'm going to have something comma 59 in just a moment. Oops. Something comma 59. And so what I'm going to do is come right back over here and substitute 59 in for y. So that's going to give me 372 minus 6 times 59. And when I do all that computation, I get x to be 18, which means there's 18 students in a van, 59 students in a bus. And these next two are just simple non-context problems. So we're going to look at using substitution. And since this one's already solved for y, I know y is equal to negative 3x plus 5, so that's going to go right and substitute in for that y. So I'm going to get 5x minus 4 times negative 3x plus 5 is equal to negative 3. So now I'm going to distribute, and I get 5x plus 12x minus 20 is equal to negative 3. I'm in terms of x, so that's going to give me 17x minus 20 equals negative 3. And if I add 20, I'm going to get 17x is equal to 17, so therefore x is equal to 1. And then since I know x is equal to 1, I'm just going to come right back over here, and that's going to give me negative 3 times 1 plus 5. So that'll be negative 3 plus 5, or that'll be 2. So my ordered pair is 1, 2. And the second one's very similar. I know that y is 5x minus 7, so I'm just going to substitute here. So I get negative 3x minus 2 times 5x minus 7 is equal to negative 12. So I'm going to distribute the negative 2, and I'm going to get negative 3x minus 10x plus 14 equal to negative 2. And that'll give me negative 13x plus 14 equals negative 2. I'm going to subtract 14. I'm going to get negative 13x equal to negative 26. So x is equal to 2. And since I know this first equation was y equals 5 times 2 minus 7, it's going to be 10 minus 7, or y is equal to 3. So my ordered pair would be 2, 3. This is using substitution. It's nice when you already know what a variable equals, you can substitute into the other equation. And similar to this one here, I know that negative 5x plus y equals negative 3, so I'm going to solve for y, and that's going to give me, I'm going to add the 5x over here to the right side, so I have 5x minus 3, and I know that this is going to go and substitute for y over here. So 3x minus 8 times 5x minus 3 is equal to 24. So if I distribute, I get 3x minus 40 plus 24. Excuse me, that's 40x plus 24 is equal to 24. So what I get is negative 37x plus 24 is equal to 24. And so when I subtract 24, it looks like I'm going to get 0. And negative 37x is equal to 0. That's okay. That just means that x is going to equal 0. So if x equals 0, I'm substituting right back here. So that's going to be 5 times 0 is 0. So y would be negative 3. So the solution would be 0, negative 3 for part A. And for the second one, I see that y has a coefficient of 1 here. So I'm going to solve for y. So I'm going to add 5x to the right side. So I'm going to have 5x plus 19. And I know that this expression is equal to y. So it's going to go here. So negative 3x minus 8 times 5x plus 19 is equal to 20. And distribute again. And I get negative 3x minus 40x minus, and I have negative 8 times 19, and that's going to be negative 152 equals 20. So if I combine here, I'm going to get negative 43x, and I'm going to add the 152 over here, and that's going to give me 172. And 172 divided by negative 43, and I'm going to x equal negative 4. So since x is negative 4, I'm just going to substitute right here. So 5 times negative 4 plus 19, so that'd be negative 20 plus 19, or negative 1 for y. So in the second one would be negative 4, negative 1 as the solution. So again, go back and look at some of these. Also, you may want to look at some of the equations and the links that I have in the presentations in the Google folder for examples of looking at solving systems by substitution. So I gave you a couple of links there in the week 10 slides. So check that out, and also remember the quizzes that are attached to the earlier email that was sent out. So, and I'll reattach them to this video as well. Thank you for your time. Look back over it, and we'll see you in about a week. Thanks.